Good morning, students. We are learning water resource engineering and hydrology. We are discussing about hydrological parameters, where in today's lecture we will discuss about infiltration. In the previous lecture we have seen various factors that are affecting infiltration. We have discussed about the measurement of infiltration. While in today's lecture we will go slightly deep in this topic and we will discuss about infiltration indices. Well, what is infiltration indices, or we can say what is infiltration index? Well, the infiltration capacity of a soil can be determined experimentally by subjecting an experimental plot to rainfall rates in excess of infiltration capacity and by measuring the surface runoff. Well, for the small areas that having the uniform infiltration characteristics, the runoff volume can be estimated by subtracting the infiltration from the design rainfall. Well, talking about infiltration index, infiltration index is the average rate of loss such that the volume of rainfall in excess of that rainfall rate will be equal to the direct runoff. Thus, the average constant value of infiltration rate, that is generally known as the infiltration index. Well, there are two different types of infiltration rate we have, that is the phi index and W index. Let's discuss about the phi index. Well, phi index is the average rate of rainfall such that the volume of rainfall in excess of the rainfall rate, that is equal to the volume of surface runoff. The value of phi index can be derived from the rainfall hydrograph and the resulting surface runoff volume by trial and error method. We are having a formula to find out the phi index, as well as this is the hydrograph that we have talked about, wherein the above portion of the phi index is considered as the surface runoff and the below part is the basin recharge, that volume of water that is stored below the ground. Okay, now the phi index value can be determined or can be given by phi is equals to P minus R upon TR, where P is the precipitation, R is the runoff, and TR is the total time for rainfall. Well, for the determination of phi index, a horizontal line is to be drawn on the hydrograph as shown in figure. So it should be such that the shaded area above the line, that is here mentioned as the runoff, is called as the volume of surface runoff, and the undashed area, which is this plain area, okay, this unshaded area below the horizontal line is representing all the losses that includes interception, depression storage, and the infiltration. But it is assumed that these losses are due to the infiltration only. If the shaded area is not equal to the volume of measured surface runoff, the horizontal line is then shifted upward or downward till this condition that is not satisfied. So therefore the determination of phi index needs a few trials. The phi index can be determined for each storm for which the surface runoff volume has been measured. Well, also the amount of rainfall in excessive manner for the phi index is called as the rainfall excess. The phi index is useful for the unit hydrograph analysis to determine the pattern of rainfall excess, because the index accounts for the total abstraction, that is interception, depression or the infiltration losses, can also be used to estimate the surface runoff from a given particular hydrograph. It is especially useful for predicting the infiltration from a storm that occurring over a large basin for which the infiltration capacity curve cannot be easily determined. Well, if there is a uniform rainfall over the basin, the infiltration index, that is the phi index, can also be determined by the equation that is suggested by the Central Water Commission, that is I minus R divided by 24. Here I is nothing but the intensity of the rainfall and R is the runoff in centimeter, that is from 24-hour rainfall. Okay, so this was all about the phi index. Let's discuss on W index. Well, W index is the average of infiltration during the period of rainfall when the rainfall intensity exceeds the infiltration rate. The equation of W index is P minus R minus SR upon TR, wherein the W index is the rate of infiltration that always should be in centimeter per hour. P is the total precipitation, R is the total runoff, SR is the surface retentions, and TR is the total duration of rainfall. That should be in hour. Well, W index is more accurate than the phi index just because it excludes the interception and depression loss which are considered as a part of infiltration. Well, W index is always less than the phi index because it is difficult to estimate the depression and the interception loss. W index is not commonly used in practice for the finding of infiltration index. Well, in practice, this W index can be used to estimate the runoff coefficient, that is K, and the formula is I minus W upon I, where I is the intensity of rainfall, that is in centimeter per hour. Now there is one more parameter, that is W minimum index. The minimum value of W index is called as the W minimum index. The value of this index is obtained when the soil is very wet. At this particular stage, because of the effect of depression, storage and the interception losses, we can neglect these things. Now W index and the phi index are approximately equal when you are comparing it with W minimum index. Okay, so these were two indexes we have for the infiltration rate. Now let's discuss one example on it. Well, the question says that the rate of rainfall for the successive 30-minute of period for 3-hour storm are 1.5, 3.2, 4.3, 2.7, 2.1 and 1.2 centimeter per hour. Well, the surface runoff in response to the storm is estimated to be 3 centimeter. So here we have surface runoff also. Now we have to determine phi index and W index with considering a total of depression and the interception loss as 1 centimeter. Well, to find out the phi index, we have two different things. First is I and the T. I is rate of rainfall and T is time in hours. Well, before finding phi index, first of all we have to assume any of given rate of rainfall as the phi index. So from all this value we have to assume a particular value from where the rate of rainfall would be excessive. So let us assume that the phi index, that is greater than 1.5 centimeter per hour. So below 1.5 centimeter per hour intensity would be neglected from the calculation. Well, we are having a formula of runoff is equal to sigma I minus phi index into T. So let's substitute the value. R is equals to 3 centimeter and T is equals to 30 minute. We have to convert this 30 minute into hour. Okay. So by substituting all this value, we are having R is equals to 3.2 minus 5, because we have assumed that phi index is greater than 1.5. So 1.5 and the below value of 1.5 will be neglected from this calculation. So 3.2 minus phi index plus 4.3 minus 5i plus 2.7 minus 5i plus 2.1 minus 5i. We are not taking 1.2 in the consideration because it is below the 1.5. And T is in minute, that is 30. So we have to convert it into hour. So 30 by 60. Now by calculating this value, we are having one equation, that is 3 is equals to 12.3 minus 4 into 5i into 0.5. Well, at last we will find the phi index as a 1.575 centimeter per hour. So we have assumed phi index as a greater than 1.5 centimeter per hour, and that actually we get. So the assumption was right. So the phi index is 1.575 centimeter per hour. Now let's move on to the W index. Well, for the W index we have a formula. Wi is equals to P minus R minus SR upon TR. Here P is the precipitation, and precipitation should be always in centimeter. Here we do not have precipitation directly. So from the rate of rainfall we have to determine the precipitation value. So P is equals to 1.5 plus 3.2 plus 4.3 plus 2.7 plus 2.1 plus 1.2 into 30 by 60. So what we did, we have multiplied the rate of rainfall with the time so that we will get the value of precipitation. So P is equals to 15 into 0.5, that is 7.5 centimeter. Then after, R is the surface runoff, that is 3 centimeter, and SR is equal to surface retention, okay, that is of depression and interception, that the value is 1 centimeter. At last, the duration of rainfall, that is 3 hours. 30 minutes is the successive period of rainfall, but the total time duration, that is 3 hours storm. So total duration of rainfall that we considered as a 3 hour. Now substitute all this value in the formula. So Wi is equals to 7.5, that is precipitation, 3 that is surface runoff, and 1 that is surface retention, and divided by 3, that is the total time duration of rainfall. So Wi is 1.166 centimeter per hour. So this is how we can calculate phi index as well as W index. Okay. So thank you so much, students, for your kind attention. I hope you understand the topic of infiltration indices thoroughly. Thank you so much. We will see you in the next lecture.